Hello students, welcome to our Asian International School online class. This is your second class on the topic reflection. Today we are going to learn few formulas regarding this curve mirror, and also we are going to do few numericals. So let's see, the first formula is for focal length, finding focal length. So focal length is equals to radius of curvature by 2. That means it is the half of the radius of curvature of that mirror. So r by 2. Second formula is the magnification formula. Any image formed by a curved mirror, it will be it can be magnified in a smaller size, it can be magnified in a larger size, it can also be of same size. Depending on the position of the object from the mirror, it will be enlarged, it will be smaller, or it will be same size. Now to understand that, to learn that, or to calculate that magnification, we have a formula. The formula is m equals to minus v by u. That means magnification equals to minus of the image distance by the object distance. Remember, for a mirror you have this minus sign. For a lens you don't have this minus sign. For a lens it is only v by u, and also it is equal to the height of the image by height of the object. That means the ratio between the image and the object height is also the value of m. Next, let's see one sum. The first sum is saying the radius of curvature of a spherical mirror is 20 centimeter. What is the focal length? This is a very easy direct sum. It is focal length we have to find out, and the radius of curvature given. So radius of curvature is 20, so focal length will be r by 2, 20 by 2, that is 10 centimeter. Next, one more same sum. Find the focal length of a convex mirror. This is a convex mirror whose radius of curvature is 32 centimeter. So same sum, same formula for all kind of spherical mirrors. You have the same formula, r equals to 2f. So here r equals to 2f is put, and f is found. F equals to 16 by doing 32 by 2. Next, number 3, this sum is for magnification. A concave mirror may produces 3 times magnified enlarged real image. Okay, we have to focus on this thing. 3 times enlarged, and also it is a real image by a concave mirror for an object placed 10 centimeter in front of it. That means u is given, u is 10 centimeter, object distance is 10 centimeter, and object distance is always taken as minus. You have to understand that object distance is always taken as minus. So where is the image located? You have to find out the distance of the image from the mirror. Formula is minus b by u, m equals to minus b by u. Now m is given, m is 3, but one thing we have to we also need to know here, that for a concave mirror producing 3 times magnified real image, for a real image formed by a concave mirror, the image will be upside down. If the image is upside down, then the magnification is negative. It's a more than 1, the value is more than 1, the magnification value is more than 1, but the sign is minus, because it's a upside down image. So if we take that into account, the name will be minus v by u. If we put the value, if you see the formula v will be then minus mu. Now m is given minus 3, and u will be minus 10. So if we do this calculation, it will be minus 30 centimeter. That means the image is 30 centimeter away from the mirror, and also it is at the side of the object, where the side of the object and the side of the image with respect to the mirror will be same. That means if the object from the mirror is at left side, then the image is also at the left side. Now to understand this sign convention, this minus plus, which one will be minus, which one will be plus, for which formula, we have some convention here. The conventions are written here. If we see, According to this, the Cartesian sign convention, all distances are measured from the pole of the spherical mirror. We have to understand this, that distance for an object or image is always measured from the pole of the mirror. Because the mirror is a curved one, so the distance from an object to the mirror can be different depending on where you are measuring. If it is top side of the mirror, then it will be away. If it is the bulky side of the mirror, it will be in front. So to eliminate that confusion, we have this one fixed rule. The rule is that we always find the distance of anything, object or image, whatever, from the mirror, from the pole of the mirror. Next, the distance measured in the direction of incident of light are always taken positive. It is always you have to take this, that distance in the direction of the light is always taken as positive, and vice versa. Height, the heights above the principal axis for a mirror taken positive, and vice versa. Means the height of an object, if it is standing up on the principal axis, it is taken positive, and if the image is also standing up, then also the image will be taken as positive. For M, for magnification, also we just saw here that magnification, it was a real image, and in case of a real image, since it is upside down, it's magnified, enlarged upside down image. So what will happen, the magnification is taken as -3. You see, 3 times we have taken as -3 over here. So minus sign is coming because it's a real image, it's upside down image, it's not an erect, so that's why minus. That is what it is telling here. The height of above the principal axis are positive, and height below will be negative. For a convex mirror, M is plus and less than 1. It is always true for a convex mirror. The magnification is always positive because the object is always standing up, as object is standing up, and also the image is also standing up for a convex mirror, because it forms a virtual and erect image always, and they are always plus. M will be always plus. Also it is shorter, the M will be plus but less than 1. In case of concave mirror, M is plus when the image is virtual, yeah, or just like the convex one, and M is minus when it is a real image. I just told you that here we have taken M minus because it was a real image. That is only here told that M is minus when image formed is real. One more very important point to remember, that object distance is usually taken as negative for both the mirrors. If you take the object distance always negative, then the light comes from left side, and like this picture, like this picture, you see the object is always the left side of the mirror, so this distance is always negative. And this case, this is the image, you can see this is the image, this image is at the right side of the mirror, so the image distance will come positive. That is what it is telling here. And if by chance, if the image was also coming at this side, at the left side of the mirror, then the image distance will also be taken as negative. These are very important points we have to remember while doing numericals. Okay. Next, see one of the most important formula for this chapter, that is the mirror formula, 1 by v plus 1 by equals to 1 by f. Now v is, you know, it is the image distance, u is the object distance, and f is the focal length. And here this formula, the derivation of this formula is not in your syllabus, so we will not go into that. We'll just know that this is the formula which is there, and we are going to use this for different numericals. Let's look into one sum. Here an object is placed at a distance of 10 cm from a convex mirror of focal length 15 cm. Find the position and nature. It's a very straightforward sum. Object distance given, focal length given, we have to find the image distance and also the nature of the image. Okay, let's see. The drawing is given over here. You can see this is the convex mirror, the focal length is here, it is given, this is the focus point, so it is at 15 cm. An object is placed here at 10 centimeter. It's an arrow, this is the object we have taken. So light going on and reflecting, again going reflecting from pole, and this is the image formed. We know this, how the images are forming. So after the image is formed, so if we see that the image is placed within the focus, and also it's upright, erect, and also it's smaller, little smaller than the object. Now if we look into the calculation, so the formula we are going to use this one, 1 by v plus 1 by u equals to 1 by f. So from there 1 by f, which is 15 given here. Now in case of convex mirror, we can see the focal length is at the right side, so focal length is right side is always taken positive, so that's why f is plus 15, and the object is placed at the left side of the mirror, that's why u is taken as minus 10. So this minus 10 for u and plus 15 for f is placed here with their plus minus sign respectively. From there we got the v is coming 6 plus 6, that means the v is plus 6, that means it is at the right side and also 6 centimeter away from the pole behind the mirror, and also virtual, it is also virtual. We are seeing it is virtual because there is no light actually passing through the mirror, it's just our imagination that there is a object present, there is something present which is the image, so it's a virtual image. That's why it is a virtual image. Characteristics, if we go for this diagram, for this sum, characteristics will be, it is a virtual image, it is a diminished image, and it's upright or erect. One more sum like this. So in this case, an object 5 centimeter in length is placed at a distance of 20 centimeter in front of convex mirror of radius of curvature 30 centimeter. Find the position of the image and also its nature. Okay, similar sum, we are going to use this. First we have to understand that radius of curvature given here, radius of curvature is r, which is 30. So we have to find out the focal length, which is found here directly. Focal length will be 30 by 2, which is 15. Also here the object size is given, that means we need to find the image size also. Now the distance of the u value, which is the distance from the object, is 20 centimeter given. Now again, once again we have taken u as minus 20, and since it is a convex mirror, so f is always plus, so f is plus 15. From here we got the f value, and it will be plus, and u will be minus 20. H is also, h means here the height of the object, which is 5 centimeter. Now using the formula 1 by v plus 1 by u equals to 1 by f, here we have put the value of u is minus 20 and f is here plus 15. So from here, if we do the calculation, 1 by v is this 1 by 15 plus 1 by 20, which is giving us v equals to 60 by 7. Now this value will be something about 8.5 or something. If we do the division, it will be 8 point something. Okay, this is here, it is given 8.57, it will come 8.57. so that means the distance of the image from the pole is 8.57. What kind of image? Now the nature of the image, since we are seeing that the v is plus, that means the image must be virtual, because at the plus means it is placed at the right side of the mirror. So right side of the mirror, there is no real light can pass through the mirror and meet at a point, so obviously it is a virtual. Anything at the right side, image form at the right side is always a virtual one, so it's a virtual one, and also it is erect one. If you see that hi by ho, then hi is coming plus 3.3 centimeter by putting the value of v and u, and hi is coming 3.3 centimeter. That means it is a virtual one, and also it is erect one. Also one more thing, this formula is coming from the magnification formula that I showed you here. M is minus v by u equals to h2 by h1, or image distance by object distance. This formula is used over here. That's how you got the hi, or the image size. So I hope you understood this. Now one sum is given here for you to practice for your homework. Please do the practice, please do the sum, and we will do more sums. And in order to get very confident and strong in this part of this physics, doing numericals from the reflection or diffraction, we have to practice sums like this in our practice time. So please do it, and that's it for this video, and we'll see you in the next one. Thank you.